A single rogue asteroid, barely a kilometer wide, drifting silently at the edge of a solar system, could one day be swallowed whole by its own star without leaving a single trace behind. No flash, no warning, no debris field, just gone. But what's even crazier is that this is the smallest, gentlest version of a much darker pattern hiding across the universe. Galaxies do not just contain stars. Some of them hunt their own stars, strip them, crush them, or erase them entirely, and the methods are stranger than anything science fiction has invented. Tidal disruption is where this story begins. A tidal disruption event happens when a star wanders too close to a supermassive black hole and gets pulled apart by gravity before it can even fall in. The side of the star facing the black hole gets yanked harder than the far side, and the star stretches into a long, glowing thread of plasma, like taffy pulled until it snaps. Astronomers have watched this happen from Earth, watched a star's light suddenly flare and then fade, as its own material gets shredded and swallowed. In 2018, one such event was observed brightening a distant galaxy's core for months, before the star's remains disappeared entirely into the dark. But a star, ripped apart, at least leaves a signature behind, a scream of light for astronomers to catch. The next method leaves nothing at all. Direct collapse is quieter and somehow colder. Some stars, especially the largest ones near a galaxy's center, do not explode when they die. Their cores are too massive for an explosion to have the strength to escape. Instead, the entire star collapses inward on itself, all at once, in silence. One moment, there is a star. The next there is only a black hole where the light used to be. Astronomers call this a failed supernova, and it may be one of the most common ways a large galaxy quietly erases a piece of itself. New star. No light. No warning. But if a galaxy can lose a star without anyone even noticing, what happens when it loses hundreds of them at once, deliberately, on purpose? That is where dense stellar environments come in. At the crowded centers of some galaxies, stars are packed so closely together that gravity itself becomes a trap. In these regions, stars do not just orbit a black hole, they collide with each other, merge, and get flung into unstable paths that eventually spiral inward. Over cosmic timescales, a galactic center can act like a slow grinder, pulling star after star into its gravitational well, until entire populations are consumed. Some galactic nuclei are estimated to lose stars at a rate high enough that, over billions of years, they reshape the structure of the galaxy itself. Take a normal spiral galaxy, pack its center into a space smaller than a single star system, and you get a machine that feeds on its own population continuously. If you have made it this far into how a galaxy secretly consumes itself, drop a like and subscribe, because the next entry turns an ordinary black hole into something that can strip a star bare over and over again without ever finishing the job. Repeated partial disruption is that entry, and it is stranger than a single clean kill. Sometimes a star does not get fully destroyed in one pass. Instead, it survives a first brush with a black hole, loses a layer of its outer material, and swings back out into space, wounded but intact. Then it returns and loses more. Some stars appear to be caught in this cycle, orbiting back again and again, shedding mass each time until there is almost nothing left. Picture a star, orbit after orbit, arriving smaller each time, until eventually the core that remains is barely large enough to call a star at all. This is not one event. It is a slow execution, stretched across years or centuries, one orbit at a time, and that leaves us with the question of what waits for the leftover remnant once even that final sliver is gone. That answer lies in tidal stripping over generational timescales, where a galaxy does not devour stars individually, but strips entire star clusters bare. Globular clusters, tight balls containing hundreds of thousands of stars, orbit within larger galaxies. As they pass close to a galaxy's dense central regions, gravity pulls loosely bound stars away from the outer edges of the cluster, leaving long trailing streams behind. Over time, an entire cluster can be picked apart, star by star, until only a bare, stripped skeleton remains, orbiting a galaxy that has quietly absorbed thousands of its former members. This is not destruction in an instant. It is erosion measured in orbits, a galaxy patiently consuming a smaller structure the way tides wear down a shoreline, one star pulled away at a time. But stripping a cluster from the outside is one thing. What if the danger comes from inside the star itself? That shift takes us to stellar mass ejection through extreme rotation, where a star can begin tearing itself apart before a black hole ever touches it. Some massive stars spin so fast, near the very edge of what physics allows, that their own outer layers begin flying off into space. The centrifugal pull at the equator becomes strong enough to overpower gravity's grip on the star's surface. Layer by layer, the star sheds itself, growing smaller and stranger with each passing rotation. Picture a star spinning so violently it is peeling like an onion, flinging its own atmosphere outward in expanding shells, long before its final collapse. In these cases, a galaxy does not even need to reach out and grab a star. The star begins consuming itself, one unstable rotation at a time. But losing your outer layers voluntarily is nothing compared to being hunted by something you cannot see coming at all. That is the danger posed by rogue black holes and neutron stars drifting silently through the galactic disk, remnants of long-dead stars no longer anchored to any visible system. These objects carry no light of their own, and betray their presence only when they pass close enough to bend the path of something nearby. A rogue black hole could drift through a region filled with ordinary stars, and slowly begin pulling material from any that stray too close, feeding in complete silence, undetectable, until the damage is already visible from light years away. Estimates suggest our own galaxy could host tens of millions of these wandering remnants, unseen and unaccounted for. Somewhere in the dark spaces between the stars you can see, one may already be feeding. If invisible predators drifting through the disk feel unsettling, the next mechanism operates on a scale that makes individual stars seem almost irrelevant. Galactic mergers do not devour stars, one at a time. They devour entire populations at once. When two galaxies collide, their gravitational fields tangle violently, flinging stars out of their orbits entirely. Some stars are ejected from their home galaxy completely, cast into intergalactic space to drift alone forever. Others are pulled inward toward the newly merged galaxy's center, funneled directly into the feeding zone of a supermassive black hole. During a major merger, a galaxy's central black hole can grow dramatically within a relatively short cosmic window, fed by a sudden flood of stellar material it would otherwise never have encountered. A single merger event can reshape which stars belong to a galaxy at all, and which ones simply vanish into it. And once you understand mergers, a deeper truth emerges, one that reframes everything already explained. A galaxy is never a fixed population of stars. It is a constantly shifting boundary, gaining stars through collisions, losing them to ejection, and quietly consuming others from within. The tidal disruption from the very first entry and the merger-driven feeding frenzy just described are not separate stories. They are the same process, operating at wildly different scales, one star at a time, or trillions at once. A galaxy is less like a fixed structure and more like a slow, patient organism, always trading mass with its surroundings. Which brings us to the deepest and strangest possibility of all, one that current physics has not yet fully resolved. Some models suggest that dark matter, the invisible mass making up most of a galaxy's gravitational pull, may interact with dying stars in ways scientists still do not fully understand, potentially altering how a star's core collapses in the densest regions of a galaxy. If true, the very fabric a galaxy is built from might be quietly shaping how its stars die, an unseen hand nudging every collapse, every disruption, every silent disappearance already described. We have never confirmed this directly, but the possibility remains open, unresolved, and unsettling. A galaxy, then, is not simply a container holding stars in place. It is an active gravitational architecture that creates, feeds on, and ultimately reclaims the very light it produces. Every star you can see tonight is, in some sense, on borrowed time, part of a system that has been quietly consuming its own population since the moment it formed. If this journey through the ways a galaxy devours its own light made you feel smaller than you did 5 minutes ago, that means it worked. Subscribe before you look up at the night sky the same way again, and if you are ready to keep exploring what waits in the dark spaces between the stars, the next video on this channel is already waiting for you.